Now, in the last lecture, we have done for 116.5 times AC. Now we'll be doing for other 16.5 times AC. Right? So for this, we'll be working on the ducting design entirely. So let's start with this. I'll freeze the layers which are not required. So now I have to work at this particular point. So here, what is each diffuse is how much? So 1600 CFM minus 7. I guess it should be in calculation as well, right? Someone try to enter. Hi, Vinod. Yeah, if you remember, we had each diffuser, 12 and 14 numbers we got it. So that's around 12 is 525 and yeah, 11 and 15, right? So if I'm not wrong, 525 and 564. Let's check once anyway. What is 7,900? I have to remove 1,600, right? So is equal to 7,900 divided by 7,900 CFM is each one, and I mean, AHU fluid rate, and then I have to do minus 6,000, 1,600 is equal to this minus 1,600 I have to do it, and then divide that value by how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers is equal to this value divided by 12. So totally 525 CFM. Right, so each one I have to design it for 525 CFM. Yeah, this is 560 and this is 525 CFM. You have to work on the design. You agree? So I'll start with this one. The main duct airflow rate is same, so I can copy it a similar one. Right? Let's change it to this one. Should that. Okay, so here this is exactly coming over. So I would like to adjust my unit in such a way that it's not obstructing my. Let's take it aside something like this. Right. Now what I would like to do is I would like to take a branch over here. Branch over here. So how much is one? Each branch is how much? 525 CFM alva, right?
520.
So 525 into 2 is how much? 1050 CFM.
1050.
Yeah. So this is what design for 1050 CFM. 1050 CFM. Head loss is 0.1. And this is 18 inches. So that is 10 inches. Offset 250. So it is in inches, right? So 10 inches. So CFM. Fillet radius. Always remember your internal radius should be 150 and 6 inches. Why invalid? Fillet radius. Oh, sorry. This is inches, right? Yeah. Offset 10 inches. Done. 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 What is that size? This is 10 inches by 18 inches. And this is how much? 1050. Alva?
Mm. So,
This is right. Then again, I have to make this particular one. I have to, remaining F flow rate, let's see. So 7,900, and here I'll provide one column. So total, how much it will be? 7,900 minus is equal to 7,900. This is the total airflow rate. These are the number of colors. Let's say each one is 525. Pending. Pending is equal to this minus of 525 into three such colors have gone till now. So 6325 CFM. So remaining air flow rate is 60 because 1, 2, and 3. All these three are supplied using this. That's the reason. Understood? Am I clear or not?
Yeah, yeah. Yes, sir.
Yeah. So now the air flow rate is how much? 6325. So I'll make it as 6325. 6325 CFM, yeah, 1490 FPM is not greater than 1500. So it is 38 inches. Offset 38 inches. 38 inches. Luckily, it's exactly intersecting. If it's not intersecting, I'll theoretically explain you later how we're going to do it. So here we have done that. So now don't you think I have to give colors for all these elements? Very
Mm,
simple, right? Now only thing is this 1600 CFM I have to distribute it over here. So let me just use some colors. So I'll use a similar color, 18 inch, 525 CFM alva. So if it is 525 CFM, 525 CFM, head loss is okay. What is our neck size we thought? 15 by 15 inches. Neck is sufficient even for this also, obviously. I'll just cross check it. 400 FPM or anything. So 15 inches, 12 inches, and 17 inches is coming. So 15 by 15 is fine for us. Now again, 525. Velocity is 600 or something because it's a collar. Let's say it is 8 inches by 18. So same collar size, you can use it over here again. You agree?
mm,
You have very minor difference in airflow. It's just done. So this, I'll copy it and some locations. Done. Okay, this guy over here. Okay. Okay. Let's see what I do. So from here, I have to calculate the remaining airflow rate over here. So what is airflow rate? That is a, oh shit, we forgot to, okay, anyway, uh, that is 6300. That is, we should always write it whenever it is a 6300. And anyway, this is 38 inches by 18 inches. Okay. Yeah. So now again, I'll copy it over here. That, so, touching this. Yes, I will copy it. Stretch it. So now what I have to do, I have to take this 1600 CFM airflow rate over here. Right, so again, I'll take a branch over here, 1600 CFM. So I'll write it as 1600 CFM. Head loss is the 0.1, 1600, 0.1. And this I'll take it as 18 inches, so 14 inches. Um, 14 inches. Select radius, 6 inches. Select radius, 6 inches, 14 inches. Now again, what I have to do, I have to calculate for, we have to calculate what is the flow rate over here. 1 feet means 12, 14 inches by 14 inches by 18 inches, and the duct size is 1600 cm. And let's see if that. . Now what I have to do, I have to, this internal distribution, we'll do it again. So we'll first complete this part. So out of 6,300, again, we have got one more collar. We have completed it. So that's 4. Uh, then out of that 5,800, again, 5,800 minus 1,600. Uh, minus 1,600 CFM. So remaining is only 4,200 CFM. So this I have to design it with 4,200 CFM. You agree?
Mm. Mm.
So this is 4,200 CFM. 4,200 CFM, point 1. So that is 28 inches it will come. Offset 28 inches it will come. So now this is intersecting. You agree?
Yes, sir.
So we have two options of doing it over here. So obviously one of I'm just showing you both the options already. So one option is cut it like this. They'll fabricate it like that. That fabricated directly they'll do it. This is option number 1. Understood?
Mm-hmm.
Option number 2 is you can create something like this. So this line, uh, copy, I'll take it over here. Then after certain this thing, again we'll increase it for other 300 mm or something. Oh, sorry, this is inches, alva. Later I'm forgetting that. So make it like this. You can make it like this also. Understand?
Mm.
Am I clear?
Yes, sir.
This is second option. Third option is you can do it here. So here you will remaining. I mean, instead of raising it over here, you're increasing it over elbow. You understood, or you want me to show you that as well?
Mm. Okay. Mm.
Understood, no?
Yes, sir.
So here I'll take this particular flow rate. So what is this particular one we have got it?
5,000.
Uh, 28 inches by
Mm.
F flow rate is 4,200. No? Sorry. So this is 4,200 CFM. So now we have to continue providing collars for all this ducting. So we just provide a ducting here. It's, we are not doing this at all, right? Yeah. It's actually wrong. In fact, all the shoe pieces are wrong. You guys didn't tell me. This should be in the
Yes,
direction of the
sir.
flow, alva.
So page to be.
You guys tell me, then tell me. It should be in reverse fashion. Always remember, shoe piece should be in the direction of the airflow.
Mm.
Um, of course, I'll use reducer. Don't worry, that time we'll able to take it. So now what I have to do after again 2 or 3 numbers, I can go for a reducer again.
Mm. Three numbers
Right.
too.
So remaining is how much is remaining? 4,200 is pending. So 4,200 means here this value is how many? 1, 2, 3, 4, 4, 5, 6, 7. So 7 are done. So it is 2,625. You agree?
Mm.
So it is 2,625. 2,625 CFM. So here it's 18 by 18 inches offset, 24 inches at 600 mm. Trim 18 inches. I have to do it. This entire thing I'll make it as 9 inches on the other side. So that's 18 inches. So this guy is 18 inches by 18 inches. What is the flow rate?
2000.
2625 CFM. 2625 CFM. 2625 CFM. This is done. Okay. So once this is done, now don't you think I can again use a reducer after this three or two numbers? Right. So I'll again add two more to it, 7, 8, 9, right? Then it will be 1575 CFM. So this value will be 1575 CFM. Offset 24. So CFM 1575. 18 means it's so I can use this thing or not. I can go for 14 inches by 16 inches or something. 7 inches on the other side. Done. So this will directly give me this is the value. Yeah, 16 inches by sorry 14 inches. 7 to the 14 inches by 16 inches. Flow rate is 1575 CFM. 1575 CFM. So, so this will go till this point. So stretch this cable here.
Show pitch direction.
Yeah, I changed it. So yes. I change again. Change it, no? Model.
Mm.
No.
That class
Right.
the
Done. Last ones. Done. So this completes our total ducting at this point. Now, don't you think you have to do ducting for this guy? So here
Mm.
again, I would like to do 1600. So here what I would like to do is out of 1600, 800 I would like to throw it on this grill and 800 I would like to throw it on this grill. Is it fine? 800 for this particular grill and remaining 800 I would like to throw it away here. That's it.
Mm.
So what I would like to do is I would like to take it as 800.1 again. That's again 10 inches to that size is 18 inches anyway. So this I'll make it as a 18 inches means it's 8 inches. So this is again 8 inches. And then again offset 8 inches. This I can use an increase or reducer to make it because 8 by 18 is stupid. So I'll go for like for 12 inches or something. 12 by 12. Or here also I can make it actually. Instead of here, I'll just change it, please don't mind. What I would like to do is here, it's 18 inches, right? Sorry, 14
Mm.
inches, alva. Once this is 14 inches, what I would like to do is here, I would like to change it to like, different width, let's say 1600, right? 600 cfm. Point one. So instead, I'll make it as 12 inches by 20 inches. So offset 20 inches. I would like to make it as uh, offset 24. No. So this particular one will be 20 by what is the size? 20 by 12 inches. So increase the width in this I'm making it as 12 inches. So now what I would like to do is this I'll make it as a 12 800 cfm. So it is 12 inches by 12 inches on the other side. So here I can make it as 12 inches. Now the previous one is also not wrong anyway. Fill
Mm.
it. Um, yeah, make both as because equally anyway it is. So well, try to do something out of it. So this will be 12 inches by 12 inches. This is 800 cfm first. Yeah. Huh. So we can directly take it over here. So similarly, when this guy over here as well. So this will provide a side throw. So from there, we'll go for a side throw and then it will come down. I'll make a section later on and I'll explain you how it is being done. Don't worry. Okay. So let's say at this location, I would like to provide some collars over here. Okay. So 1600 CF, 800 CFM. Shall I go for two number of 400 CFMs?
Mm.
And here, the width of the collar is how much? The grill is how much? It's only 4 inches. So we'll go for something like this. So what is the size of this guy? 4 inches, right? So what is this? One, yeah, 400 CFM. 400 CFM. I want to have around say 500 FPM or something. And then the width is 40 inches by 4 inches. I have to consider that. So I'll consider some three numbers or else 800 divided by 3 is how much? 266.66 CFM. So 266 CFM. 266 CFM. Velocity is 500. 4 inches means 26 inches. And offset 26 inches. Offset 4 inches. 40 inches is too much. That means nearly 1 is to 10, though collars. It's okay, we can use it, but I'll try to avoid that. It's too much. So anyway, rectangle. Because 4 into 40 is basically 1 is to 10 ratio. So I made it to three collars instead of one collar. Understood? Done. So from here again, I can copy it over here and this over here. Of course, grill volume is large. We can actually reduce it if there's a budget issue. But aesthetically, let's say the architect wants to have end-to-end grill. So count for collar. So what is this collar? What is the size of the collar? How many inches? 26 inches by 4 inches, alwa? 26 by 4 inches.
That
266.66 or 266 April. Each, how many
that
numbers are there? Six
ratio
numbers. Yeah, you
one
were
is to
telling
one
something, sir?
ratio 1:4 ratio it will not count here.
Yeah, for
Like
callers, we'll not do it at all, because the distance is too small.
mm,
Previously, I got 1 is to 40, which I really didn't like it. That's the reason I made it
mhm,
into three callers. Of course, even that also you can provide.
mm.
That's the reason for callers, we have a rule that it shouldn't be greater than 1.5 meters.
Okay, yeah, yeah, yeah. Correct.
Understood?
Mm,
And
mm,
moreover, we'll have a grill or collar damper inserted into it so that it will not bend.
mm,
Understood? Yeah. So with this, we have done the basic duct design. Now, don't you think you have to provide my volume control dampers?
mm,
So at all bends, for example, here and here I have to provide a volume control damper. Here I have to provide a volume control damper. Here I'll provide volume control damper. Here again I'll not provide because in a single airflow rate you can't have more than one this thing air volume control damper because volume control damper will have a very large static losses. Understood?
mm,
So I have some standard blocks. I'll share you those blocks as well. There's a standard blocks. ECD. I'll just copy it from this guy. SC1 by 25. Basically, that was an mm. So just rotate it. Move. So we use dynamic blocks. So one is over here. Other one is over here. Then you have one over here as well. Oh, sorry. At this location you have. These are the branches that you have, Alva. Always remember if you have gypsum ceiling, you might have to provide a trapdoor. Else you'll not be able to access it afterwards. So if it's a gypsum ceiling and you have a volume control damper, you have to provide a trapdoor unless there is some kind of side access or something. Yeah,
mm.
please remember that. So this volume control dampers have placed it, and here anyway it's only two locations. I've got it. This is actually at this location I have to place it. These are the volume control dampers that we have it. Yeah. So with this, we have done the entire ducting design. Now, don't you think we have to go for acoustic insulation, thermal insulation?
Mm,
You remember the rules I've explained earlier?
mm.
What is the
Yes.
use of acoustic insulation?
It is that to dampen the noise.
No. So how much feet we have to install from the start of the mouthpiece? So from the starting of the equipment, you should have at least 5 meters of your acoustic insulation. That's around 15 feet. Remaining everything, you will make it with thermal insulation. Understood?
Mm,
I'll just isolate it and I'll show you. Now I'd like to make a acoustic insulation over here, right? Yeah. So this I'll make it with acoustic insulation. Of course, VCD is there. That location will not do it. So polyline from here, 15 feet. 15 feet is still over here. So at this till this location, I can go for this one. So I'll go for here and here. I'll directly locate this thing. It's coming in use current. It should be. No? Ah, hmm. And acoustic will go for ANSI 45. Where is ANSI 45? G30 and G37. Yeah, this we can use it. Right around. Okay, here it's and G37 that uses in gray. Yeah. We'll change the color from this one to gray or something. Correct. Similarly, here also 15 feet I have to go for this one. 15 feet we have to get it. So still over here it will come roughly till over here and till this point. So I'll just hatch it till over here. I'll consider this as acoustic insulation. Reminding everything I can make as thermal insulation. Yeah, including your collars and all. Olden days we used to do only the tail end. But now we have changed that procedure. The reason is simple because if you have gone for only at the tail end, temperature at the final grills will be odd. That's the reason. And temperature at the final end, it will be like very hot. Understood?
Hmm.
That's the reason we have stopped. We are doing entire thermal insulation nowadays. Am I clear?
Yes.
Okay, so this is acoustic insulation, and we have done the thermal insulation. So this completes our this ducting. Then what we have to do, we have to provide outdoor units for this case. We have to provide a outdoor unit for this equipment as well as for this equipment, and we have to provide a drain for everything. We have to provide a fresh air provision. All those things are still pending. Understood? So till now, you have got any queries? No. Please respond.
No, sir. No.
Sure. Okay.
Hmm.
Cool. So now what we'll do is we'll create a drain pipe, fresh air, all those options we'll do it. Let's say today we can complete section out, or else tomorrow I'll just explain you how to make a sectional view for this drawing. Okay. So with this, we can actually wind off this entire project. That's the reason. So now, don't you think you have to work on the drain point or not? Drain provision? Yes. So for these units, it will be above the fall ceiling, so I can use gravity and I can push it to the toilets. So I'll just go for, and first of all, this particular one, I'll move it like this, and then I'll do cycling. So now what I have to do is for this, I have to work on the copper piping so that I'll be connecting it from this gate to the outdoor unit and the drain. So first we'll work on the drain pipe. And always remember your drain diameter actually, the slope that you basically provide theoretically is did I explain you guys about U-trap by the way or not? I don't remember.
No.
Okay. So for all the equipment, it's mandatory for us to provide something called as U-trap in the drain portion. Okay. So what is that U-trap is? For example, I'll just show you an example. Let's say I've got a equipment. Okay. Equipment is there or a ductable unit or anything is there. So from the ductable unit, directly I've taken a drain pipe and then we have directly provided to the nearest toilet. Can you give a guarantee that this fan which is sucking the air, it will not suck any air from the toilet, from the drain toilet? No one can, right? You can't give a guarantee. It can pull the air from the reverse from this one. Yes or no?
Yes.
Because it will have certain static pressure. So to avoid that, basically, more than the static pressure to the fan, you will have something called as a drain. So in the elevation view, if you see it, your drain will be provided like this. Let's say your diameter of the pipe is say 32 mm, offset 1.5 inches. Okay, so what we do is we basically provide the elbows, something like this. Let for that radius anyway. That's whatever PVC manufacturers provide the same elbow. And then what you do is, let's say this is your height. Let's say your static pressure of the fan is, say, for example, 2 inches. So you can take even 3 inches also to be safer. 3 inches, you'll take it over here. So this is a minimum dia you have, a minimum height that you have to maintain on the upward scale. Okay, similarly, I'll just a second, copy. Minimum it should be like 2 inches or whatever it is. So yeah. We'll provide a U-trap something like this and just explain you. You can keep it like this. So basically, the height of 3 inches or 4 inches, you make sure that you maintain it. Understood? So basically, whenever the water enters, it has to push the water through this. So here, just a second, because when the water comes here, automatically it gets level till here. Alva. So just a second, I'm just trying to think of the basics. Uh, because obviously when the water flows like this, it has to come over here. Yeah. Yeah, this will be your, so this will be the direction. So when you provide it, what will happen basically in this direction, if you provide it, whenever water comes in, it has to raise it to a certain extent and then it will go. You agree? Of course, your main line is going. So because of that, what will happen? Your air should suck against the gravity. You agree or not? Hello? Okay, please respond. I'm audible.
You are audible, sir.
Okay. So when the whenever we are trying to push the let's say this is the equipment, from here we're pushing the water. So when it is pushing, when this airflow, when the water should come in the reverse direction, don't you think you have to work against the gravity? Yeah, it should be
Yeah.
like this, sorry. So when it has to work against, so this is a U-trap, sorry. Direction, I'm confusing it. Sorry. So let's say this is our equipment that we have. So now what will happen when we do it like this? What is going to happen is you are making sure that you have to work against the gravity so that your fan will not be able to suck the water. Understood or not? Second
Yeah.
advantage is if you are connecting it to any of the drain portion or anything, cockroaches or any other thing cannot come through the stored water, because no matter what, don't you think the water will always be stored at this point? From here to here, the water will be stored or not? Whether the unit is running or not, this entire region, the water will be stored with the water. You agree? Yes or no?
Yeah.
So for that reason, what will happen when you have it something like this? Of course, you provide it with a slope. This will be in a slight slope fashion. So if you see it, just a second, just show. So like this slight slope, you'll provide it. Understood? So when you provide it with certain slope, automatically, water will flow. And here, when of course, this also should be in a sloped fashion only. Yeah, it will be something. Understood. So when you provide it a drain point, something like that, so due to gravity, anyway, water will flow. But whenever you have stopped the equipment, say probably 1 month or even 1 day or 2 days also, water will be stored in this so that you make sure that small rodents or insects and all cannot swim through this water and it will not enter into your indoor space. So both ways you have protection. One thing is you're making sure the fan is not sucking air from the reverse direction. Second thing is you're making sure even pesticides or any insects or anything is not pests or insects are not entering into your space. Understood or not?
Yeah.
Now, if you have multiple equipments, you need not provide for all the equipments. At the last point, you can connect your U-trap. Anywhere in the circuit, you can provide a U-trap. It's not mandatory that you have to provide only near the indoor unit. Am I clear?
Mhm.
Now, coming to this one is the drain portion. So, so general slope of the drain that we have to consider is 1 inch per every 50 feet. The drain that we generally use is 1 inch per every 50 feet. Plumbing is 1 is to 100, but in this case, it's 1 inch per every 50 feet. That means if you say it in each two means, let's say 1 inch is how much? 25 mm, 12, right? Is equal to 12 into 50. So 1 is to 180 is also fine. Understood? So 1 is to 180 is the worst slope. You can always provide better slope than this. 1 is to 100, 1 is to 50, according to your site conditions. Understood or not? Sorry, it's not even this one. 1 inch is 12 meter, 1 inch per every 50 feet, alva. So is equal to 1 inch is equal to 1 inch. 50 is 15 to 12. Sorry. So 1 is to 600 is the worst case you can go for HVC drain. Okay, this is the worst case thing that you have to consider. But generally, we try to do plumbing rules only, which is 1 is to 100. Understood or not? Theoretically, we say worst case is, minimum slope that you have to maintain is 1 inch per every 50 feet of piping. Clear? But as because it's only drain, you don't have any, because normal plumbing drain means you have some solids or anything. But in this case, it's just condensate water that will go. You agree? So for that
Yeah,
reason, the slope
definitely.
is 1 is to 600 is also 1 is to 600 is also worst case is fine. Understood? Yeah, you were telling something. Sorry.
No, 1:100 is normal.
Yeah, normally we use 1 is to 100 because in plumbing we generally use 1 is to 100. That's the reason. But not only that, second important thing also whether that height is available for you in the ceiling or not, you have to see. Whenever, especially you're working on high wall units, okay, because you chase the wall and you do it. But when you use ductable split AC or anything, in those cases, your equipment will occupy maximum height. And from there to false ceiling, beneath that height only, you have to adjust this drain. Obviously, you can't bring the drain beneath the false ceiling, right? Yes or no?
Yeah,
So you have to consider the slope. So here, let us design the slope. So coming to the drain diameters, theoretically they say even up to 10 tons also, your 25 dia is fine. Generally, what do we do is up to 5.5 tons or 8 tons, will 5.5 tons we go for 25 More than that, you go for 32 it should be fine. Understand? For example, in this case, I'll directly go for 32 dia. How much tonnage also 32, 50 is more than adequate for any project. Understood? Hello? The diameter of the pipe we can go is this one. Let's say, just a sec. I'll write a straight away. Let's say this is my toilet. I wanted to provide it to the female toilet over here. Offset 32 so 1.5 inches. Let offset from 3 2p. Probably I'm using a U trap over here. That's the reason I just showed it like this. Offset. Let I can do it like this, or I might have thrown it on the backside wall. It depends on the site condition. So I have to give it to the nearest flow drain or anything. Clear? Am I clear? Excuse me. Now we'll go to the next one as well. This particular drain point as well. From here, let's say I oh, the deductible split is general on the back side will have it, but I think then let's offset 4. Sure. So I'll just write it as 32 condensate drain pipe connected to nearest flow drain or something. First capacity is C 32 drain would be flow trap. Understood. So like this, similarly, we'll do for all the red portion, including your high volume units or everything. Doesn't matter. Clear? Understood or not? So with this, we have completed our main ducting. So only minor thing that's pending is location of the outdoor units that we'll do it tomorrow, and then creating a section, preparing a layout. And once that's done, then I'll show you on the next lectures, we'll have a discussion again on BUQ, how to generate the total quantity used in this project, including your reference joints, everything. I'll show you how to prepare a BUQ. Understood enough?
Mm. Okay.
So tomorrow we'll create a section. So tomorrow also it will be almost like a drafting class where we'll create a section like this, XX. And to that, I'll make an entire section as such for a room space. Clear? Of course, if you use
Okay.
Rivet, section details and all is not required because once you make it, it automatically will be able to create it. But anyway, as it's CAD, you're supposed to do it. Clear?
Mm.
So we'll wind up for today.
Yes, sir.
That's the reason it's a matter of taking a bit longer duration. So tomorrow again we'll connect back.
Okay.
Okay, fine.
Thank you.